Okay, now let's move to new section, that is applied one, that is about relative motion. Relative motion, okay. So here this contain relative displacement, relative velocity and relative acceleration, three sections. Definitely for your A-level examination, there will be relative velocity question, 11 part B. 11 part B, relative velocity question. Then 12 part A will be system of wedges that comes with relative acceleration. Relative acceleration. And part A, there will be system of pulleys that also something deals with relative acceleration and Newton's laws. Relative acceleration and Newton's laws. Okay, then we're going to complete that part now onwards. That is about relative motion. Okay, then sometimes there can be some relations with part A, first one, collision part, there can be some relative acceleration, some small combinations. With projectile also there can be some small combinations with relative motion. Okay, likewise, and linear motion also there will be something like relative velocity time graph. Relative velocity time graph. Okay, those are the things. This is very simple lesson, small lesson, important lesson. Okay, write down topic, relative motion. Relative motion. Relative motion. Okay. Now the concept like this, see this one, you consider here a man A, here another man B, here another man C. See, here initially here these two displaced by 5 meters and here displacement by 4 meters. 4 meters. They are not moving. Okay, they are stationary people. Okay, not moving. Then when A observe about B, then he can see B is displacement 5 meters this way, no? Then we say that one, displacement of B with respect to A. To A, displacement 5 meters this way, no? Then here we denote displacement of B with respect to A is 5 meters here this way. Okay. Then further when you consider, when C observe about B, then to C 4 meters this way, no? Therefore displacement of C with respect to B is 4 meters in the direction. Then displacement of B with respect to A is this, displacement of C with respect to B is that. Then when you consider, let's say this one 3 meters. So when you consider this one, that is displacement of C with respect to A is here this length, that is 5 meters, no? 5 meters. Take this angle alpha. Then here we say displacement of C with respect to A is 5 meters inclination alpha. That is about displacements. So the relative displacement here to C, relative displacement 4 meters, here to A 3 meters. They are different, no? They are different. Therefore, these two have relative displacement between A and C. Now further you consider this. Here a bus that moving with velocity 10 meters per second, 10 meters per second. Then there's stationary observer here, say A, and here outside the bus there's another stationary observer, say B. And here a passenger, let's say C, that moves with velocity 2 meters per second. 2 meters per second, okay? Moves with velocity 2 meters per second. So when A observe C, he can see C is moving with velocity 2 meters per second. No? When A observes C, he can see C moves with velocity 2 meters per second. But if B observe about C, he can see 2 plus 10 velocity, 12 meters per second. Then both of them, A and B, observe about one single man, that is C. But appear in velocity different. A, he can see 2 meters per second. B, he can see 12 meters per second. Then appear in velocity different. Therefore, we say between A and B, that's relative motion. Okay? Between A and B, that's relative motion. That is relative velocity concept. Okay? Then we need to discuss the things about this type of relative motions. Usually, all of these frames are moving with constant velocities. Bus moves with velocity 10 meters per second. Man moves with velocity 2 meters per second. Likewise, constant velocity motion. So we mainly discuss about that type of frames. Okay? Then we need to discuss the relative motion like this condition. Okay, just write down. First sketch these diagrams, these two diagrams, just sketch it. Here displacement of B with respect to C. Now this is figure 1. Here figure 2. Figure 1 and figure 2. Okay, just write. The figure 1 represent positions of stationary observers, capital A, B, C. Stationary observers, capital A, B, C. A can observe the B is 3 meters due east. is 3 meters due east. And C can observe, simple B is 4 meters due north. They are relative displacements. Those vectors are different. Therefore, here we say there's relative displacement between A and C. Relative displacement between A and C. Okay, go to next line and write down. The figure 2 represent a bus moves with velocity 10 meters per second. And two stationary observers A and B. One is inside the bus, and the other one is outside the bus. The one is inside the bus, the other one is outside the bus. A passenger C move forward with 2 meters per second velocity. Passenger C moves with 2 meters per second velocity. Therefore, go to next line, write down. A can observe the velocity of C as 2 meters per second, here this way. 2 meters per second this way. And we can observe the velocity of C as 12 meters per square second this way. 12 meters per square second here this way. To A that appear in 2 meters per square second, to B that is 12 meters per square seconds. Now, okay, now just write. Both A and B observe the motion of C. Within bracket, same object. But appearing velocities are different. Therefore, Therefore, here we say there's relative motion between A and B. There's relative motion between A and B. There's relative motion between A and B. Okay. Now check this one. Here we have special notations. Now usually you consider S displacement, V velocity, A acceleration, no? Displacement. Therefore, displacement of B with respect to A we can represent like this. Displacement of B with respect to A. With respect to A. Here this represents displacement of B with respect to A. So that is 3 meters this way. Likewise we can denote. Okay. Here displacement of B with respect to A. Here this is the thing. And similarly you can denote displacement of C with respect to A. Displacement of C with respect to A. Here it is. Angle alpha. Here 5 meters, no? 5 meters. So here this one displacement of C with respect to A. Then observer is A, no? Observer is A. That's how we denote. Then here this case, velocity of C inside the bus we denote. Before that, velocity of bus. If the frame not given, you think that is with respect to Earth. Then usually we say velocity of bus 2 meters per second. Then that means velocity of bus with respect to Earth. That is all sure thing. But the passenger C moves with 2 meters per second inside the bus. Then frame is given, no? Like inside the bus. So if it is given inside the bus, mean the velocity given with respect to bus. Okay. Then A observe the velocity of C as 2 meters per second, mean A observe, no? Then velocity of C with respect to A is 2 meters per second. Then B observe the velocity of C as 12 meters per second, mean with respect to B, velocity of C is 2 meters per second. Okay. If the frame is given, then with respect to that frame. If the frame is not given, definitely you take that with respect to Earth. Okay. Reference not given. If the reference not given, you consider that is surely with respect to Earth. Okay. Then here velocity of bus 10 meters per second, mean velocity of bus with respect to Earth. Here 10 meters per second. Here notation, velocity of bus with respect to Earth. Then velocity of C with respect to A. Here 2 meters per second. 2 meters per second. Then velocity of C with respect to B. Velocity of C with respect to B, to him 2 plus 10, 12. 12 meters per second. Okay. Likewise we can see. Then when B observe A, then let's say velocity of A with respect to B, no? So velocity of A with respect to B 10 meters per second. 10 meters per second. Likewise we can denote the things. Okay, those are simple notations. So all these are vectors. Displacement, acceleration, velocity, all are vectors, no? All are vectors. Therefore, any vector theorem here applicable. Any vector theorem here we can apply. Okay, just write notations. First you write this one. First you write this. Then here SAB. By the side write down displacement of A with respect to B. Here VAB. Here velocity of A with respect to B. With respect to B. Here AB mean acceleration of A with respect to B. Those are the notations. Here this represents velocity of A with respect to B. Just put that notation. Okay. Now further you see SAB and SBA. They are not same, no? They are not same. SAB, SBA, they are different. But SAB equal minus SBA. Only direction has changed, no? Only directions change. Then remember SAB equal minus SBA. For velocity acceleration both are same. Then SAB magnitude equal SBA magnitude, no? SAB magnitude equal SBA magnitude. Okay, put them, just put them. Okay. Now see one another. Here you consider VAB. Here this say U. VAB U. Therefore, VBA means opposite direction U. Opposite direction U. Then only direction will change. Only direction will change. Okay. VAB U this say, then VBA mean opposite direction U. Opposite direction U. Put that one as well. These are important notations. These are important notations. Okay. So in all are connect with vectors, then vector relations here. Vector relation is here. Then don't worry about the things, all are vectors. Okay. Put that one as well. Okay. Now with that notation, you better write these relations. With that notation, just write those notations. With here displacement of B with respect to 3 meters. Here we underline because it is a vector. Here we underline because it is a vector. Displacement of C with respect to A. Likewise, velocity of bus with respect to 10 meters per second. Velocity of C with respect to 2 meters per second. Likewise, write it notations. Write it notations. Now write this special point. Write this special point. If the velocity of bus 10 meters per second due north, if the velocity of bus 10 meters per second due north means the velocity of the bus with respect to earth, the velocity of the bus with respect to earth 10 meters per second due north. If the velocity of the bus 10 meters per second due north mean the velocity of the bus with respect to earth is 10 meters per second due north. Within bracket write down the reference is not mentioned here. The reference is not mentioned here. The reference is not mentioned here. Therefore, take that is given with respect to earth. Then take that is given with respect to earth. That is given with respect to earth. Okay. Next star mark, write down. If A observe the velocity of B means, if A observe the velocity of B means, if A observe the velocity of B means, B 2 meters per second due north means, 2 meters per second due north mean 2 meters per second due north means velocity of B with respect to A, the velocity of B with respect to A is 2 meters per second due north. Two meters per second due north. Within bracket, here the reference is given. Here the reference is given. Here the reference is given. Therefore, with respect to that reference, is the given velocity. Is the given velocity. Put another star mark. The velocity of A with respect to the velocity of A with respect to B means, the velocity of A with respect to B means the velocity of A with respect to B means the velocity of A where the B observe, velocity of A where the B observe, or the velocity of A, the velocity of A when B is at rest, when B is at rest, velocity of A when B is at rest. Okay, that is very important point. Huh? Then with respect to A mean we have to stop A. With respect to B mean we have to stop B. We have to stop B. Okay, let's see how to do that. Okay, see this. You consider here 3 meters per second A velocity, and here B velocity 2 meters per second. Okay, then I'm going to consider here this is with respect to Earth. With respect to Earth. So these are with respect to Earth. Now I'm going to consider here velocity with respect to A. Velocity with respect to A, okay? That means we have to stop A. Then I'm going to convert this into with respect to A. Then the meaning of this, stop A. Stop A. Then to stop this A, we have to cancel this. That means you give opposite direction 3 meters per second. Now here it is. Here 2 meters per second. Here B, here A. Here 3 meters per second. You give opposite direction. Here this system you give 3 meters per second. Then the resultant will be, here A is at rest now. B velocity, opposite direction 3. Then 2, 3, here 1 meters per second. No? 1 meters per second. So this is relative velocity. That is the velocity of A with respect to velocity of B with respect to A. Here with respect to A. With respect to A. Okay. Then here 1 meters per second. Here we can denote velocity of B with respect to Earth is opposite direction 1 meters per second. No? 1 meters per second. Here this way. You have to stop this A. Therefore, to cancel this 3 meters per second, give opposite direction 3 meters per second full system. Then here this becomes 0, this becomes 1. 1. That is relative velocity. That is simple theory. So then same direction motion, then we get velocity difference as the relative velocity. No? For same direction, we get relative velocity as velocity difference. Now further you consider another example. Here 4 meters per second. Here 2 meters per second. Say A, say B. Then here with respect to Earth. That is with respect to Earth. Now let's see how to get with respect to B. With respect to B. That means you have to stop B. You have to stop B. Then to stop B, you give opposite direction 2, no? Then here the system now, for here 2, then full system you give opposite direction 2. Therefore this becomes 0. This becomes 0. Now the result is B is at rest. A 4 plus 2, 6. Then we say this one, velocity of A with respect to B is 6 meters per second. 6 meters per second. That is relative velocity finding technique. This is very simple concept, okay? Very simple concept. Then all deals with vectors. All deals with vectors. Okay, put that example first. Okay. Now let's see further few examples. Now you consider here A, velocity U, here B, say velocity V. Then velocity of B with respect to A. See this, Anna? I'm going to write directly. I'm going to write the things directly. Velocity of A with respect to B. Velocity of B with respect to A. Now we need to stop A, no? Then give opposite direction u. This becomes 0, then here v minus u, no? V minus u. That is relative velocity. Then velocity of A with respect to B. Now you have to stop B. Then give opposite direction V. Then here V u minus V. U minus V. U minus V. Okay. Consider another example. Here A, velocity u. Here B, velocity V. Okay. Then velocity of A with respect to B, velocity of A with respect to B. Now you stop B. Then give opposite direction V, no? Then here this become u plus C, no? Then here u plus C. Here this A. Then you consider third one. Here A, its velocity u. Here B, its velocity V like this. Then velocity of A with respect to B, you have to stop B. Give downward B, then B becomes 0. Then here u plus V. Here we have two components, u and V. Here the resultant. Then we can find resultant, say this is V1. V1 equal u squared plus V square root alpha tan inverse V divided by u. Tan inverse V divided by u. Okay. Likewise, we can easily find relative velocities. Okay, that is simple concept. So if you need to find velocity of A with respect to B, you stop B. To stop B, you give opposite direction velocity as B. No? That is simple concept. Okay. You get that examples. Okay. Now relative velocity, very simple concept. Here this is the concept now. Then velocity of B with respect to A mean we have to stop A. So we have theorem called relative velocity theorem. And for displacement we have theorem called relative displacement theorem. And for acceleration we have theorem, relative acceleration theorem. But the concept is that. Okay. Then see this one. You consider here A, B, C. Then here this is AB vector and this is BC vector and this is AC vector. Vector triangle, vector addition. Now here AB vector plus BC vector equal AC vector, no? AC vector. Resultant is AC for now. Now further we can say AB vector, if these are point on earth, then we can say AB vector means displacement of B with respect to A, no? Then AB vector represents displacement of B with respect to A. Here these are positions of earth. Then here we can denote displacement of B with respect to A. Then BC means displacement of C, directed one C, no? Then displacement of C with respect to B. Then here AC represent displacement of C with respect to A, no? Starting point A, directed position C. Therefore, displacement of C with respect to A given here. Okay. Now, further you see this one, I'm gonna write this one by subjecting AB or yeah, AB, then SBA. Put this on the other side, SCA minus SCB. We know notations. SBA mean SCA. Here minus you can change to plus by interchanging these two. SBC. SBC. So further I write this one SBA equal, change these two terms, SBC plus SCA. Swap this. So here it is. Then SBA equal SBC plus SCA. This is called relative displacement theorem. The thing is simple. So here displacement we write as sum of two displacement. So displacement of B with respect to A, you start with B, ends with A. Common C will be there. Start with B, ends with A, common C will be there. Okay. Here relative displacement theorem. When we differentiate this one once with time, then we can convert that into V, BA, V, BC, V, CA. This is called relative velocity theorem. So anyway, velocity we write as sum of two velocities, start with B, ends with A, here common one. Relative velocity theorem. So when we differentiate that one again with time, that becomes A, BA, A, BC, A, CA. That is called relative acceleration theorem. Relative acceleration theorem. That's how we take those theorems. Here relative displacement theorem. Here relative velocity theorem. Here relative acceleration theorem. That's the thing. Okay? You better note that one. Better note. Then further, here onwards we consider about relative velocity theorem. So that is previous on our concept. That concept we obtained by the theorem. So we are going to use this theorem. Okay. Right? Okay, now let's see how to apply relative velocity theorem. Okay, see this one, see this one. Here consider A, its velocity u. Consider here B, its velocity, here this way v. Then the reference not given, no? The reference not given, directly velocity given. That means those are given with respect to Earth, no? Therefore, represent velocity of A with respect to Earth is u. Velocity of B with respect to Earth is v. Then if you need to find velocity of A with respect to B, if you need to find velocity of A with respect to B, now you get relative velocity theorem. You get relative velocity theorem. So here velocity addition. Start with A, ends with B. Here you put common value, common thing. here that common one is E. You write this way. Okay. Then VAB equal VAE plus VEB. That is relative velocity theorem. So VAE U, VEB, here VBE upward B, then VEB mean downward B, no? V. That's how we get. Therefore here U, V, then the resultant will be the corresponding thing. Say V1, then V1 equal U squared plus V square root. Then alpha mean tan inverse V divided by U, no? Then velocity mean a vector. You have to write both magnitude and direction, both. Okay, that's how we obtain. So we did that one by the concept previously. So velocity of A with respect to B mean we have to stop B, no? Then give downward velocity B. Then here U, here V. That is here. Then same thing we can appear here. Then we need to practice this theorem application. We have to practice the theorem application. Anyway, here this relative velocity theorem mean triangle law of vector addition. That's it. Relative velocity theorem mean triangle law of vector addition. Relative displacement theorem, same. Relative acceleration theorem, same. All are same. Then all are triangle law of vector addition. Okay. Do that example with relative velocity theorem. Okay. Now I'll give you few questions. You find these things by relative velocity theorem, okay? By relative velocity theorem. Okay, do one by one. Do one by one with relative velocity theorem. Okay, take time. Here find VAB now. Then write VAE plus VEB. Here relative velocity theorem. Then addition of two velocities start with A, ends with B. Then common one will be E, no? Then by that time you find the case. VAE upward 6, then VEB opposite 8. Then here vector addition we can do by triangle law of vector addition, or we can do by resolving forces. No, here no need to resolve, we can consider resultant value, no, perpendicular vectors. No? Okay, continue, take time. First you practice to write relative velocity theorem. First practice that. Okay, VAE, addition of velocity start with A, ends with E, here common one B. Then VAB, VBA given, then VAB mean opposite direction 4. Here BE downward 3. Then you can find resultant, no? You can find resultant. VAB, addition of two velocities, start with A, ends with B, common one E. Then VAE, it is given 5 upward. VEB, BE given, then opposite direction 5. Then finally you can find resultant value. So you have to find resultant, okay, magnitude and direction both. Then VAE, addition of two velocities, start with A, ends with E, common one put B. Then AB, BA given, AB mean opposite direction, then BE given U. Then VAE, right, velocity sum start with A, ends with E, common B. Then AB, here BA given, AB down, BE given V. Okay, now with that one you see, we have specially triangle law of vector addition, no? We have specially triangle law of vector addition in vectors. So here also these are vectors, no? All these are vectors. Therefore, for these cases we can sketch triangles to find resultant. Here especially these are velocities, then we say those are velocity triangle. Okay? Then here, when you consider addition of two vectors like this, A and B, we go with this path. We sketch vector A first, then at the end point we sketch the other vector B. Therefore, here these two coincident. Therefore, let's denote this one P, Q. Then here you take Q and R. Then here P, Q coincident. Here R. The resultant is PR. Resultant is PR vector, no? That is triangle of vector addition. Okay? Then for these cases, we can sketch velocity triangles. So that PQR notation very important. Then first you take here, you can take any one here, say P, Q. Then here start the other vector QR. Then sketch it. Here PQ, 6. Here PQ. At the end point, QR. Yeah, that is 8. You sketch according to some scale. Then resultant is this. Start with P, ends with R. Here PQ plus QR vector. Resultant is this. Then here this is called triangle, velocity triangle. Okay. So you can start with first vector and go to second vector, or you can start with second vector and go to first vector. Whatever it is okay. So when you start with here this one, it goes like this 8. Then the other one upward 6. Here 8, upward 6. Then the resultant is this. The triangles somewhat different, but resultant same. Same magnitude, same direction. Okay. Then you can start with any vector. So anyway, that is called triangle of vector addition. Velocity triangle. So if you consider another one, you take one vector, let's say here PQ. Then at the end point, you start the other one, QR. Then PQ, for QR3. Then here the resultant, that is velocity triangle. Then you better to sketch for each case that velocity triangle. Okay, by the side small you sketch velocity triangles. Likewise, you just sketch. So you put PQR notation, you use PQR notation and sketch velocity triangle. Do so. Now here we can easily sketch all, no? Here this is our concept, okay? This PQR notation very important. You can see that one like simple thing, but that is really important because later we have to sketch velocity triangle different way with a circle. In such case, we need to properly put PQR notation. Okay? You better write down this one. You better write down. So that is triangle law of vector addition, okay? Triangle law of vector addition. We know that one, but anyway, just write that. Okay, I'll give you another set. You find the required relative velocity by the relative velocity theorem and sketch velocity triangle, okay? Sketch velocity triangle. Okay, now continue, do soon. Question set 2. First one, VAE, 5, VBE, like previous one, okay? 10. So some cases we can't sketch triangle. We can't sketch triangles for some cases, okay? So this is, we can't sketch. For this one, we can't sketch triangle. But anyway, we can find, na? Okay, continue. I need relative velocity theorem, okay? Do soon. Okay, do soon. So we can't sketch velocity triangles, huh? Just we can find relative velocities because all line same line now. Do soon. Apply relative velocity theorem. Anyway, you identify velocities along same line, same direction, relative velocity is the difference between the velocities. Then opposite direction, Opposite direction, relative velocity is the addition. No? Okay, do soon. Okay, here check your answers. VAB, VAE, VEB. Check your answers. Okay, AE 5, 10. VAE, VEB. Here EA upward 5, EB downward 15. 15. Here the resultant 5. Here the resultant 15. 10. Resultant 10. Here AE, AB, BE. AB 10, BE 5. 15. AE, AB, BE. AB upward U, BE downward V. Here we don't know whether U greater than V or V greater than U, but anyway you write here upward U minus V. VAE, VAB, VBE. Then AB, here BA, no? Then opposite U, BE, V. U plus V. U plus V. Okay, check your answers. Okay. Now let's see another concept. Write down shortest distance between. Write down shortest distance between two objects. Shortest distance between two objects. Shortest distance between two objects. Okay, this is another important part. Usually this will come with advanced level paper, shortest distance. Now let's consider here object A, object B. Both of them are stationary objects. If both of them are stationary objects, here shortest distance and maximum distance, all distance are D, no? That won't change. Here two objects stationary. Two objects are stationary. Now you consider one object moving. So here A is stationary, B moving along this path. Definitely they meet, no? Definitely they meet. Then shortest distance 0. Definitely they meet. Okay. Now A and B will meet. Then here A, here B, Here consider velocity like this. A is stationary, B moving. Now along this velocity direction, B will move, no? Then take here D. So when you consider this perpendicular length, that is equal the distance, the shortest distance between A and B. Now here AB distance, displacement D. So when it move like this, so initial displacement D, so if somewhere here the corresponding displacement is this, if somewhere here the corresponding displacement is this, if somewhere here the corresponding displacement this, then somewhere here corresponding displacement this, somewhere here corresponding displacement here. Then anyway, this one we call shortest distance. Okay. Then you have to sketch perpendicular to this path, no? Then this is we call shortest distance. Shortest distance. Here this is d alpha, d sin alpha. So one object moving. So here first case, second case, third case. Okay, that is shortest distance. But both of them are moving, we have to think a lot. Here one object moving, no worries. Here this is stationary. Then from that you have to sketch perpendicular to the path. So if both of them are moving, we have to think a lot. We have to stop one. So we can stop one by considering relative velocity theorem. No? By relative velocity theorem we can stop it. Okay, just write this one first. Just write. Okay. Now you better write here, better write somewhere here. If one object is moving, by side write down, if one object is moving, sketch perpendicular to the locus of sketch perpendicular to the locus of moving object from the stationary object. Perpendicular length will be the shortest distance. Perpendicular distance will be the shortest distance. Perpendicular distance will be the shortest distance. Go to next line and write down. When two objects are moving with uniform velocities, when two objects are moving with uniform velocities, to find the shortest distance, the relative velocity is used. Consider the following working rule. consider the following working rule. First one, consider the following working rule. Okay. First one, find the relative velocity. Find the relative velocity within bracket A with respect to B or B with respect to A. A with respect to B or B with respect to A. That is 1. 2. Sketch the corresponding locus. Sketch the corresponding locus. Third, sketch perpendicular to the locus from the stationary object. Sketch perpendicular to the locus from the stationary object. Okay. Now see, this is very simple concept, but commonly that always appear in examinations. Here see A. Here consider B. You consider this moves with velocity u, this moves with velocity v. Then velocity of A with respect to earth u, say initial displacement given d. Then velocity of B with respect to earth v. Then you find velocity of A with respect to B. You find one. Velocity of A with respect to B or velocity of B with respect to A. Whatever it is, okay. Then write relative velocity theorem. Start with A, ends with B, common E. Then here A, E, U. E, B, downward V. Then A, B, B, E. A, B, A, and with B, E. Then A, E, U, E, B, downward V. Okay, now here the path. Then take alpha, say V1, U squared plus V square root. Then here this is U. Okay. Now you sketch relative path. Okay, here the way. Now we know velocity of A with respect to B now. Then here stop B now. A with respect to B. Then B is at rest. Now B is at rest. A is moving, no? Now let's consider that diagram. Here B is somewhere here. Displacement D, A somewhere here. Then now B is at rest, A is moving. B is at rest, A is moving along this path. Along this velocity that move, no? Then this path we call locus. Locus of A with respect to B. Locus of A with respect to B. Now B is stationary, therefore you can sketch perpendicular. Then initial displacement D. Now here this is shortest displacement, shortest distance. So then shortest distance equal D sin alpha. That is D sin alpha, no? Then by this one you can find sin alpha. Sin alpha U V over U square plus V square root. Then dV divided by U square plus V square root, no? That is how we find shortest distance. Very simple concept. You find relative path first, sketch it, sketch perpendicular. Now B is at rest, the other one is moving. That is relative velocity concept. Okay, do that example. Okay. Now let's see another one. Let's see another one. Take this example. Now here, object A moves with velocity u, object B moves with velocity v, angle theta. You better do with me. Here displacement, initial displacement d given. Better do with me. Now velocity of A with respect to earth u, velocity of B with respect to earth v with that inclination theta. Then velocity of A with respect to B. You stop B now. Then write relative velocity theorem. AE EB. Then AEU EB opposite direction V. Here is. Now find it. You can sketch velocity triangle or you can resolve the forces, resolve the velocities. Here now u plus v cos theta, here u v sin theta, angle alpha say v1. You can find it, no? You can find. Better find v1, Pythagoras apply, u plus v cos theta v sin theta all thing root. Then simplify here u squared plus v squared plus 2uv cos theta, here the final version. Then alpha tan inverse v sin theta over u plus v cos theta. Yeah, these are general relations, okay? Resultant of two vectors. Now you sketch relative path. Then we have taken here velocity of A with respect to B. Now B is stationary. B is stationary, no? Now let's sketch it. Here AB, B is stationary. A is moving. Here B, A. Now A is moving along this path with inclination alpha with velocity v1. No? That is we call locus of A with respect to B. B is stationary. No? Locus of A with respect to B. Now we sketch perpendicular. Here shortest distance. That is d sin alpha. D sin alpha. Now we know alpha, no? D given, then sin alpha equal v sin theta over u plus v sin theta over v1. No? Then you can substitute and find. No? So anyway, complete. Okay. Now let's move a little further. You try to do this. You try to do this. Here you angle theta. Here V, initial displacement D, say A, B. Okay, you find shortest distance between them. Take a little time. Take a little time. velocity of A with respect to B, earth, angle theta u, velocity of B with respect to earth v, downward, then velocity of A with respect to B, right, relative velocity theorem, AE, EB. Upward v, then find them. You can sketch velocity triangle. So let's sketch velocity triangle. Here this is V, say PQ, here say QR. PQR. Then here the resultant. Here to the horizontal angle theta. Then to find PR, we can easily get Pythagorean theorem. Here this is V, no? U. Then here resolve U cos theta. Here U sin theta. U cos theta, U sin theta. Then find PR. V plus U sin theta U cos theta. Then you can simplify this now. Then U squared plus V squared plus 2UV sin theta. I did this direct way. So you expand and complete. So here V square, U square sin square, U square cos square will be U squared only. Then 2UV sin theta will remain. Then alpha now, tan inverse, alpha tan inverse U cos theta. U cos theta divided by here V plus U sin theta. That's how we find relative velocity. So now we know velocity of A with respect to B. Now B is at rest. You better to sketch relative path or relative locus. Let's sketch it. Now A here, B here. Now B is at rest now. Velocity of A with respect to B. B is at rest. A is moving along this path. BA along this path it moves with inclination to the vertical alpha. Yeah, alpha you sketch perpendicular. This is shortest distance now. This is velocity diagram. This is displacement diagram. Okay. Then here shortest distance. Here alpha 90 minus alpha alpha according to my one, that is d cos alpha. D cos alpha. Okay, then you can find d cos alpha. Cos alpha V plus U sin theta divided by V1. Here V1 we know U squared plus V squared plus 2UV sin theta root. That's how we get it. No? Okay. Now you consider this. We have two ships. Okay, consider two ships, capital AB. They move with velocity UV. They move with velocity UV. I'll give you a figure. Then the shortest distance given S. Shortest distance given S. Then one ship can shoot range R. Okay, just write it. Just write. Just write. Let a warship let a warship moves with velocity u due north. Moves with velocity u due north. Moves with velocity u due north. And a boat moves with velocity v due east. Moves with velocity v due east. At the first encounter, the displacement simple d, where the boat is due east of the ship. Boat on due east the dunne due west karaganna ඔය due west. Boat velocity take due west, okay. Okay, this is u, this is v. Initial displacement d. Okay. Now write, let the shortest distance between ship and the boat is s. Let the shortest distance between ship and the boat is s. And the warship can shoot in the range r, simple r, within bracket r greater than u, r greater than s. Mark danger zone of the boat. Mark danger zone of the boat. Mark danger zone of the boat. And find time. Where the boat is in danger. Okay. Now you better do with me. Here initial case, ship due north velocity u, boat due west velocity v. Okay. Then velocity of ship with respect to earth u, velocity of boat with respect to earth v. So here it says about shortest distance. So you find shortest distance now. To find that, you consider velocity of boat with respect to ship. You can take any one, okay. Then now I have stopped here ship. Then b e s b e v downward u. Then we can find resultant. Here u, here v, here the resultant. Angle alpha, value v1. We know v1 u squared plus v square root alpha tan inverse u divided by v. First you do up to that. Okay. Now let's see further analysis. So now initially ship is here, boat is here, displacement d. Now I got here velocity of boat with respect to ship, no? Okay. Then here relative path. Ship is stationary, boat is moving with velocity v1. Here along this path it moves with velocity v1. Now here the shortest distance given s. Then ship can shoot in the range r. So now ship is stationary, that r value greater than s, then range, that shooting range greater than shortest distance. Therefore from here it can shoot, here and there it can shoot. Then here this is danger zone. So that radius will be r, no? Danger zone. Here this part danger zone. Danger zone. Okay. So now boat moving like this. Then here shooting range r. From here to here, that is in danger, no? From here to here, that is in danger because that ship can shoot, no? So that is within that range, no? Here danger zone. Then you find here r given, s given, find this displacement, that is r squared minus s square root. Here this displacement we have to move, and further another displacement same. Therefore time in danger, here this displacement must move, that means 2 r square minus s square root displacement have to move with velocity along this v1, no? v1 velocity divided by v1. So that is time in danger. So this is relative path. Then now ship is stationary. From that ship it can shoot, no? Then here mark danger zone, radius r circle. Then shortest distance s given less than r. Now from here to here, that is in danger. Therefore here radius r, shortest distance s, here this displacement r square minus s square root, twice of that displacement have to move. Then twice of that displacement need to divide by its velocity. Okay. So that is the time. 2 r squared minus s square root divided by v1 u squared plus v square root. That is time in danger. Okay. Now we have done many things under relative velocity. Then we need to do only one small thing. So now we know how to sketch velocity triangle. We know how to get shortest distance between them. Okay. We know how to get relative velocities. Okay. By relative velocity theorem or direct technique. So previous all cases, quantities are given with both magnitude and direction. No? Then velocity given with magnitude and direction. We have two quantities now. Each case we have magnitude and direction. But in some cases, then both will not give. There can be some partially given data set. But previous all cases I gave two quantities with both magnitude and direction. So such a thing, we need to consider a new concept to sketch velocity triangle. We have to consider new concept to sketch velocity triangle. Okay. Now write down. Consider the following data set. Consider the following data set. Consider the following data set. Sketch velocity triangle. Sketch velocity triangle. Sketch velocity triangles for v greater than u. For v greater than u and v less than u. V greater than u and v less than u. Okay, now see this one clearly. Yeah? Here first one, VAB U upward, VBE VAE, here it is. Okay, now check this clearly. Now here we have three quantities. One contain both magnitude direction, one contain only direction magnitude, one contain only direction. No? Previously it is different. Previous case, one quantity has both magnitude direction, the other one also has again magnitude and direction. But here this is partially given, this is partially given, this is fully given. No? So here we have one that is only direction known quantity. No? Direction known quantity. You subject it and write relative velocity theorem first. So here the procedure, direction known quantity, subject and write relative velocity theorem. Start with A, end with E, here common B. Then AE direction, AB direction U, BE V. First you do up to that. Here first time, okay? Do up to that. Okay, now you see this one. Now see how to sketch velocity triangle for this. So I told you one thing about PQR notation. No? Then this is fully given. No? You mark that one as PQ vector. Then sketch it. Clearly see this. Huh? Here this is PQ. PQ. Check this one all. Then the other vector you take QR vector. QR vector. Then PQ, next QR, then resultant will be PR, no? PR. Now for QR, we know only magnitude, no? Then Q is here, R magnitude, QR magnitude V. Then let's take V greater than U case. Then Q is here, then magnitude V. Then V distance point you consider, that is on circumference of this circle. Take Q center, sketch radius V circle. Then this is possible R points. These are possible R points. No? Clearly get that one. No? First sketch PQ, Q is the center, then R we know only magnitude. Therefore, we don't know direction. Therefore, from here you consider V radius circle. Then this is possible R points. Possible R points. Then V given greater than U. No? So if V less than U case, here this case V greater than U. For V less than U case, see what will happen. Then here PQ, then QR, V distance, not exceed this point. So now it is look like this. Q center circle. Here Q center circle, radius V. Now here PR direction given, then P is here, you sketch line like this. Then R on this line, previously R on this circle, definitely R is the common point. R on this line, R on this circle, then common point will be R. Here this is u and we know radius v, then resultant equal v square minus u square root. No? Now but that triangle we can find all. This is velocity triangle. But when you consider this one, P, then PR along this line. Previously we got R on this circle, now R on this line. We don't have any common value, no? Therefore such motion not possible. Then this motion not possible for this case. Therefore the motion is not possible. That motion is not possible, no? Okay, do that example. Okay, by the side just write down, in the above data set, there are three quantities. With two quantities are partially given. Partially given. Better to subject only direction known quantity. And write relative velocity theorem. Better to subject direction known quantity, only direction known quantity, to write relative velocity theorem. Okay. That is major point. Okay. Now I'll do another one. You better do with me. Here second one, VAB, U, VBE, VAE, here this side. You do with me. Now here this is direction known quantity, subject it and write relative velocity theorem. VAB, VBE, then AE, AB, U, BEV. Then you take here PQ vector, you would say here QR vector, say here resultant PR. Put them properly. So you have to put them properly, otherwise you can't sketch the circle. Then you start with fully known thing, PQ, the next will be QR, resultant will be PR, don't change. This is P, this is R, don't change it. Now sketch PQ first. Now we have two cases, no? So let's V greater than U case. First one V greater than U, second one V less than U. We have two cases to analyze. Then sketch PQ vector. Here this is PQ. Then QR vector, magnitude V, V value greater than U. Then that exceed this P point. No? Then Q center, V radius circle. Q center, okay. Sketch properly the circle. Q center, radius V circle. Carefully sketch. Q will be center. Now PR, here this direction. Then we have R possibility here. Then here radius circle V, here this is U. Then we can find this one. That is V squared minus U square rho. Then we know direction here, direction for this and magnitude for this. We know everything. For this case, sketch PQ. Here PQ, U, QR, V radius circle, V magnitude less than U. No? Then here circle something like this. Q radius circle, Q center circle. Then PR this way. Then we can't find common R point. Therefore, this motion not possible. That motion is not possible. Okay, I'll give you 2 to do. You do this. The main point, direction non-continuity you have to subject. Direction non-continuity you have to subject. Okay, that is not compulsory, but that is important. Direction non-continuity. Thereafter, PQR notation. So you practice one first. PQR notation you have to practice that one. Don't change the order. Later you can do that one, but for now don't change. Then Q center, radius will be the magnitude non-quantity. No? Q will be the center, radius will be the magnitude non-quantity. Okay. You do this third one. Okay, you do these two. Take time. Third one, here no magnitude given. Na? Here V. Wait 1 second. VAE, here this say VBA. Here this is BA. Here AE, here BA, upward V, VBE, U, okay. VAB, downward U, VBE, VBAE, okay, now it is okay. Okay, here this one VAE, VAB, VBE, AE, AB, here AB opposite direction, V, BE, U. Then take PQ, here QR vector, here PR vector. Sketch PQ, here P, Q, magnitude V. Then QR vector U, you take V greater than U case. First V greater than U. Then here V value greater than U, QR magnitude U, no? Then here the circle. Then PR, here it is. No such motion, no? No motion, like that. Then V less than U case. Here this is V. Here PQ vector. Then circle like this. Then here PR. Now we have possible motion, radius U, no? Yeah. Then PQ, then QR. Put arrows properly. Yeah? PQ plus QR equal PR. Okay. Then similarly do the other. You subject this VAE, VAB, VBE. VAB downward U, BEV, here it is. Here PQ, QRV, here V. So take V greater than U case. V greater than U case, you can sketch this say. Q center, radius V circle. Then PR, look like this. Then there's possible R point. Then the other case, no possible motion. No? The other case, no possible motion. Complete that. Okay, that's enough relative motion for today. Yeah? That's enough relative motion for today.